Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, today I'm going to bring all of you to what we call a discussion of one of the set that I have with me right now. So I do hope that this discussion or my explanation really helps you and benefits all of you in your preparing your before your final examination. Okay, so then this is a set of the question that I have with me right now. So, for your information, that for final examination of paper SM015, there are only one papers then, okay? And then they divide into two parts, which is part A, where there are three questions, one, two, three, and part B, there will be 7 questions that provide you 75 marks. Okay. For part A, they provide you 25, and for part B, they'll provide you 75 marks. Okay, there are 7 questions, all of them 1, 2, 3, 4, 5, 6, and 7. Okay, so for what we call Pspm, for this we call for semester 1, contains of what we call question from topic 1, 2, 5, 8, 9, and 10. Okay, so class, let's get started here now. Let's start here. Okay, look at the first question here now. Limit of x approaching to 4 for x squared minus 16 divided by square root of x minus 2. Okay, so guys, girls, if I strictly substitute the value of x equal to 4 here and here, 4 squared equal to 16, so 16 minus 16 equal to 0, and square root of 4 equal to 2, then 2 minus 2 equal to 0. If it gives you 0 over 0, then the whole function is undefined or damaged. So we are trying to avoid this. Okay, do not strictly substitute the value with x equal to 4. So what are we going to do now here is we're going to multiply this with a conjugate of denominator. Then we have square root of x plus 2 divided by square root of x plus 2. Okay, so multiply this limit of x approaching to 4. Look at denominators here. Square root of x times square root of x here. Okay, because this is a conjugate, x square of x plus 2 is a conjugate for square of x minus 2. So it means that here, square of x multiplied with positive 2 and negative 2 times square of x, it clearly is 0 here. So then negative 2 times positive 2, it gives you negative 4. Okay, so then the denominators here right now, we have x minus 4. I think that we can form one of the linear for x squared minus 16, which is equal to x minus 4. Okay, x squared minus 16. X squared minus 16, we come up with x minus 4 and x plus 4. Am I right? X times x squared, 4x, negative 4x equal to 0, then negative 4 times 4 equal to 16. Then we have square root of x plus 2. So, clear between these two, x minus 4 divided by itself equal to 1 then. So, limit of x approaching to 4, we have x plus 4 and square root of x plus 2. So, what you get then? Substitute x with 4 here, 4 plus 4 equal to an 8, and square root of 4 equal to 2. 2 plus 2 equal to 4. Then it equal to 32. Okay. And then evaluate limit of square root of x squared minus 2 divided by x plus 2. This is a limit of x approaching to positive infinity and limit x approaching to negative infinity. Okay. So for B, limit of x approaching to positive infinity of square root of x squared minus 2 divided by x plus 2. Okay, so class, limit of x approaching to positive or negative infinity, we are going to refer to this x because we're going to divide every single term with the highest degree of x from denominator. And the highest degree of x from denominator is 1 here. But then, if you look at this, you might think that the highest degree of x, which is 2. But don't forget that square root of x squared is going to give you an x. Okay, so now for this one here, limit x approaching to positive infinity. So we have x squared divided by x squared minus 2 divided by x squared divided by x over x plus 2 divided by x. Okay, so we use these rules here. Square root of x squared equal to an x. So x is the highest degree of, we call degree, according to this question here, degree of x from denominator, which is power of 1. And this also considered as power of 1 here now. Okay, so x squared divided by x squared equal to 1. 2 divided by x squared equal to 0. Then here 1 and here is 0. So what we get then? It's going to give you square root of 1 minus 0 divided by 1 plus 0. So square root of 1 minus 0 equal to 1. So 1 minus 1, 1 divided by 1 equal to 1. Okay, then next, limit of x approaching to negative infinity, square root of x squared minus 2 divided by x plus 2. Okay, and again, this is, we call square root of x squared equal to modulus of x, where modulus of x, we divide into two parts here, where x for x greater than or equal to 0 or negative x for x less than 0. Okay, so now, for this case, limit x approaching to negative infinity, square root of x squared divided by x squared minus 2 divided by x squared divided by x over x plus 2 over x. And because we have x approaching to negative infinity, we come up with negative sign here. For this one, it's approaching to positive, so we add nothing. We consider this one as a positive here now. But for this one, we add up with a sign of negative. And then x approaching to negative infinity, for this one, we equal to 0. Okay, wait. It's not 0 then. This is 1. Okay. This is 1, 0, 1. And 0. So then it come up with negative square root of 1 minus 0 divided by 1 plus 0. Then it is equal to negative 1. So, from these two set of answers, which is 1 and negative 1, so we come up with a conclusion that horizontal asymptote, HA, for me, okay, I write it in short form, horizontal HA stand for horizontal asymptote. Okay, horizontal asymptote for fx, which is y equal to negative 1 and y equal to 1. Okay, so find the horizontal asymptote, if any. So this is the one, y equal to negative 1 and y equal to 1. Okay, next question. Find the derivative of the following function. So then y equal to 2x squared plus 1 divided by 2 to the power of 2x. Okay, so guys, girls, for this one, if we derive this or differentiate this based on the question here, because it's a ratio, then we have u and v. So y prime of this one, we come up with u prime multiplied with v minus u multiplied with v prime divided by v squared. Okay, but then if we modify this or make some adjustment here, 2x squared plus 1 and multiplied with 2 to the power of negative 2x. So this multiplied with this, then this we call dy dx or y prime for this one is come up with u prime multiplied with v plus u multiplied with v prime. Okay, so there are two different methods or approach that we can use it here. So then let's say if I use either one, okay, meaning that I can choose any of these two as a solution for this question here. Okay, let's say if I make it on the right side here then. So y equal to 2x squared plus 1 multiplied with 2 to the power of negative 2x. Okay, so y prime or dy dx equal to, firstly, we're going to differentiate this. 2x squared plus 1. Differentiate this, going to give you, yes, 4x. And then, okay, y prime equal to u prime multiplied with v plus u multiplied with v prime. Okay, I bring this above and here according to look at this one here now. So 4x multiplied with 2 to the power of negative 2x plus with 2x squared plus 1. Just now we differentiate 2x squared plus 1 to give you 4x. The next one, we just write this all here now, and it's time for us to differentiate this. Okay, class, y equal to a to the power of fx. Then y prime equal to, okay, firstly, we write down all this again, a to the power of fx. Multiplied with, yes, natural log of a. Next, differentiate the function of fx here, f prime x. So slowly, one by one, firstly, we can write down all this again, 2 to the power of negative 2x, then multiply with natural log of 2, okay, and differentiate this, differentiate negative 2x, it give you negative 2, okay. So then 4x, 2 power of negative 2, it means that is 4x divided by 2 to the power of 2x plus with, okay, so 2x squared multiplied with everything here, 2 power of negative 2x, natural log of 2, and then negative 2. So look at this one here now. Guys, girls, 2 power of negative 2x multiplied with natural log of 2 multiplied with negative 2. We cannot simply multiply between this negative 2 with 2 from the natural log here. No. Or this negative 2 multiplied with this 2 here. No. So guys, girls, what can we do here now is just let it be like this, okay, until the end of the solution then. So now, 2x squared, wait. I think that for this one, negative 2, we can multiply with 2x squared. So negative 2 times 2x squared, it should be negative then. Okay, 2x squared times negative 2 minus 4x squared. Okay, negative 4x squared. And then multiply with natural log of 2 divided by 2 to the power of 2x. And then 1 here. 1 multiplied with negative 2 minus 2. Okay, 1 multiplied with negative 2. Then natural log of 2 divided by 2 to the power of 2x. Okay, so simplifying this, simplifying all this, it's gonna give you, okay, look at the denominator, all of this with 2 power of 2x, am I right? Okay, all with 2 power of 2x. So then 4x minus 4x squared natural log of 2 minus 2 natural log of 2. And everything divided by 2 to the power of 2x. Okay, so you may factorize this. We have 4, 4, and 2. So take out the 2 here, and then 2x minus 2x squared natural log of 2 minus natural log of 2 divided by 2 to the power of 2x. Okay, and then between this, okay, we have natural log of 2 and natural log of 2. So then 2 class, which I think that for this time being, if you get this one, which I think that is more than enough, okay? But then according to this one here now, it is 2x minus natural log of 2 multiplied with 2x squared minus 1 and divide by 2 to the power of 2x. There you go. Okay, y equal to x minus tangent x plus 1 over 3 tangent cube x. Find dy dx in the term of tangent x. Okay, so this one here, y equal to x minus tangent x plus 1 over 3 tangent cube x. So then dy dx equal to differentiate of x equal to 1. Differentiate tangent secant square x plus with 1 over 3 is a constant. Okay, now for this one here, we are going to differentiate the power of this function first. 3 multiplied with 3. Then tangent 3 minus 1 equal to 2 x. Then differentiate the trigonometric function. Differentiate tangent secant square x. And differentiate x equal to 1. Okay, so now 3 divided by 3, we have 1 minus secant square x plus with tangent square x secant square x. Okay, so then now in the term of tangent x, meaning that we don't want to see any secant x left. Okay, so do you still remember the trigonometric identities? For example, sine square x plus cos square x equal to 1. Okay, so divide by sine square, sine square divide by sine square equal to 1. Oh no, it's not divide by sine. We're going to divide by cos. Okay, sine square, okay, everything divide by cos square x. So sine square divided by cos square equal to tangent square x. Cos square divided by cos square equal to 1. 1 over cos square equal to secant square x. So look at this one here now. Tangent square x equal to secant square x minus 1, or secant square equal to tangent square plus 1. So 1 minus secant square. Secant square equal to tangent square plus 1. Tangent square x plus 1 plus with tangent square x and another secant, which is tangent square x plus 1. Okay, now 1 minus tangent square x minus 1 plus with tangent square times tangent square, tangent to the power of 4x plus with tangent square times 1 equal to tangent square x. Okay, so then 1 minus 1 equal to 0. Tangent square minus tangent square. So what's left here now? Tangent to the power of 4x. There you go. Okay, determine the point of inflection of the curve this one here, fx equal to x to the power of 4 minus 2x cubed minus 1 using second derivative test. Okay, so let's say given here y equal to x to the power of 4 minus 2x cubed minus 1. Differentiate for the first time, 4x cubed minus 3 times 2 equal to 6x squared. Differentiate 1 equal to 0 then here. And then y double prime equal to 3 times 4 equal to 12x squared. And 2 times 6 equal to 12x. So now, we're going to find the value of x from the second derivative here. So let's make this one y double prime equal to 0, so which is 12x squared minus 12x equal to 0. Then 12x, which is x minus 1 equal to 0. With from here, then x equal to 0 or x equal to 1. So then, this value of x, just imagine that if I come up with this table, so there are two values of x, 0 and 1. Okay, just imagine that this is where x equal to 0 and x equal to 1. Okay, so let's find the range between this. This is the range for negative infinity until 0, 0 until 1, and 1 to positive infinity. So, just think of any value of x that lies in this range. Okay, make our life easier. Let's choose where the value of x equal to negative 1. Between 0 and 1, there's no other choices. Let's choose half, and this one here, 2. So then, f double prime, which is y double prime here, 12x squared minus 12x. Okay, class, substitute x negative 1 into f double prime, which is 12 negative 1 squared minus 12 times negative 1. And this one going to give you 1, and this one negative, negative, positive. So, 12 plus 12, 24, which is positive. Okay. Then next one, 1 over 2. 1 over 2 and 1 over 2. 1 over 2 square, it gives you 1 over 4. 12 divided by 4. Okay, 1 over 4. 12 divided by 4 equal to 3, and 12 divided by 2 equal to 6. 3 minus 6 equal to negative 3. Negative. And then, 12, 2 square minus 12 times 2. 2 square equal to 4. 4 times 12 is 48 minus 24 equal to positive 24. Positive. So guys, girls, we're going to look into a concavity. Okay, concavity for this one means that the mouth of the curve is facing up. Okay, the mouth of the curve is facing up. This one facing down and facing up. Okay, so it means that from here we can just imagine that the graph will be something like this. Here, here. Okay, so the point of inflection here at x equal to 0 and y equal to something, and here is 1 and something. Okay, so we're going to find out what is the point of inflection. Inflection means that the changing from the concavity facing up and facing down. So this is a point of the turning point between facing up and down. Okay, so how are we going to find the coordinate of this? Substitute into this function of y. So then y equal to 0 to the power of 4 minus 2 times 0 cubed minus 1. It gives you negative 1 here. Okay, so 0 and negative 1. So what about y when x equal to 1, then 1 power 4 minus 2, 1 cube minus 1. Okay, 1. 1 cube is 1 times 2 minus 2 minus 1. So negative 2 minus 1, negative 3 plus 1 equal to negative 2. So it is now is between the coordinate is 1 and negative 2. Okay, so that's it.